Okay, we're live. All right, and Mr. Null did something stupid. He forgot his own book. So suppose I better grab that first. For those of you that are gone, welcome to class. Hopefully you're getting a good seminar with the building trades guy that's in today. So, what was it? Brady and Nolan and Phil and Freddie. So hopefully you're having a fun time there. And obviously Kurt, I know you're going to be joining us there too with your watching on YouTube. And anyone else that may be gone for 7th period. By the way, if any of you guys ever want any of the videos, please let me know. I'm always happy to forward them to you if need be. Okay, so what we're actually going to do is we're going to be going over section 2, physical properties. You don't have to have your book open for it. Basically what I'm going to do is I'm just going to be asking you questions about the substances that I'm displaying or doing something with. And what we'll do is one of defining them, and Callie's going to be our script for us, or a scribe, I guess you could say. So thank you, Madam Scribe. Okay, now start off here. I want you to tell me the difference. Any differences that you notice between molasses, corn syrup, and vegetable oil. So what do you notice between molasses, corn syrup, and vegetable? Yeah?
Molasses is a lot thicker than the rest of them.
Yeah, it's thicker. It is thicker. So when it's really thick, how does it move?
Slow.
Very slow. Yeah. In fact, someone first hour had mentioned a term about molasses in relation to the winter times. Anyone ever heard that phrase about, being really slow and having to deal with molasses and huh? What is it? Slow as molasses in the wintertime. Yeah. Or I've always heard slower than molasses in January. Because obviously, if it's cold, it'd probably be even slower, I guess, then too. Huh? Yeah, probably wouldn't move very well. Okay. So, we have three objects. One is really, really thick. We have this one, which is, kind of, but I mean, as you can see, it's not as slow. And then this one here. The term for that, and I'll tell you what, I'll see if anyone's ever heard of it before. Is anyone in here kind of a person that likes to work with engines at all? Anybody? Huh? Oh, Dalton Kimball? I'll ask him that next period then. I bet he'd be one. And Tyler Williams wasn't here for first period, so he would have been one to ask though too. But maybe you've heard this term in reference to engine oil, to motor oil. The term is called viscosity. V-I-S-C-O-S-I-T-Y. So that's one of our first notes, definitions. So viscosity. V-I-S-C-O-S-I-T-Y. It deals with it's a substance's ability to resist flowing. A substance's ability to resist flowing. So of these three, which one is the best at resisting flowing? Molasses, yeah. So would you say, if we were to put a number to it, which one would have the highest viscosity?
Oil.
So again, viscosity is a substance's ability to resist flow. So molasses would be the highest number then, because, it's doing the best job at resisting flowing. It's not going to move very well. So the higher the number for viscosity, the thicker it is. Okay, and the more it's going to resist wanting to be moved. So if you hear the term viscosity with motor oil, it's referring to the thickness of the motor oil. Some engines you want a thicker oil. Some engines you want a thinner oil. Obviously you always want to make sure that you're putting the right oil with the right engine. In fact, does anyone happen to know, in the wintertime for your car, is it better to use a thicker oil or a thinner oil if it's really cold?
Thinner.
Thinner, yep. Because in the wintertime, what's going to happen to liquid and its ability to flow? It's going to gel up, yeah. Yep. Exactly. And you don't obviously want that to happen. So they say in the wintertime, especially if you live in really cold climates, here's not as dramatic, although I tell you what, of late it kind of has been. I think they typically recommend that you run, in most car engines, 5W30, although in the summertime you can run 10W30. I know like my wife's car, I think hers is like a thinner oil. It's like 5W20 for the summer, 0W20 for the wintertime. And they'll tell you like what temperatures you might want to start running the thinner oil at. So that's viscosity. It is a substance's ability to resist flow. And again, the higher the number, the greater the viscosity. So that is viscosity. Okay, now, my next little demo here for you. This. Nope, not a potato. Could do it with a potato, because then you'd have a potato battery, but not a potato. Okay? So,
Can we do a project with a potato?
okay, so that's disconnected. Obviously, this being connected. Now, check this out. Paper. We'll take the, whoop. Clip here. And up. Nothing's happening. Why not? Why wouldn't the bulb light up even though I had it connected to the paper?
Doesn't conduct very
Doesn't conduct. But here obviously it does. So what can you say about the metal?
Conductor.
It's a conductor. So then what is the paper? If it's not a conductor. Does anyone know the term for something that does not conduct? Okay. Let's start with conductivity. Maybe you'll happen to think of that in the meantime. Okay, so if you were to tell me it's conductive, conductivity, what is conductivity then? What is conductivity? You just told me the paper is not conductive, but the metal is. What's that mean?
How electricity runs through something?
Yeah, how well electricity runs through something, okay? So, we could say that a conductor, if you want to spell out conductor, spelled out the same way as just like a train conductor, although obviously those two mean a little bit different. So C-O-N-D-U-C-T-O-R, conductor. As Kyle very well put it, how was it you said that again? Allows electricity to...
How well electricity runs through something?
Yeah. How well, so how about, yeah, how well electricity runs through something. So something that's a good conductor, I guess you could say, allows electricity to run or flow through it. So something that's a good conductor does that. Interesting. Well, here's another one for you. Okay, now today obviously it's not so bad out there. In fact, I've heard it's pretty nice. It's supposed to get up near 40 degrees today. Well, whether it be today or whether it be another day, tell me this. Would you want to go outside dressed up as a knight from King Arthur's court, or would you rather have something else on outside? Okay? Why would it be a bad idea to be dressed up like a knight? Yeah.
Because the metal holds the cold very well.
What do you mean holds the cold?
Well, it like stays cold.
Yeah, it does. Okay, well, it does. So what if I stayed in here and I took all the time in the world ahead of time to get really warm?
With the suit, pretty soon.
Yeah, with that suit on.
Well, it'll slip a lot once you get into the cool air.
Okay. Yeah, well, okay. Whereas, what would I want to wear outside? What would I want to wear to feel comfortable?
Insulation.
Yeah, something that insulates my body, a coat. So, what does it mean to insulate? What is an insulator? Chelsea?
Well, it keeps the heat in.
Yeah, it keeps the heat in. Okay, well, what about, say, I'm sure everyone has one of these somewhere around home. A koozie. Why do you have a koozie?
Keep your
Cold in.
Keep your drink cold. But yet also, it keeps things warm and it keeps things cold. How does it do that?
trapped. How to explain it?
Yeah, it kind of traps it. Okay, whereas just metal, on the other hand, what does metal do?
Just lets it go.
Lets it go through. Okay, so I think we found another meaning for conductor for what else conductor does. So besides being able to allow electricity to flow through it, what else does a good conductor allow to flow through it? Heat, right. So a good conductor, and we're just going to add on to conductor, allows heat to flow through it well. Okay? So a good conductor allows heat to flow through it well. So then if you're an insulator, which we're just discussing now, so whether it's like a wool coat or whether it's this, what do insulators do in comparison to conductors?
They hold it.
Okay, so so in other words, it can't get through. Okay, so an insulator does not allow heat or electricity to run through it. Okay, so it's basically the opposite of a conductor. So again, an insulator spelled I-N-S-U-L-A-T-O-R. So again, an insulator does not allow electricity or heat to flow through it. So that is an insulator. So in your home, obviously you want good insulation. Keeps you warm in the wintertime, keeps you cool in the summertime. You know, kind of like the example of a coat right now versus a koozie in the summertime. You want the coat in the wintertime to trap your heat, to keep it from escaping to outside of your body. Or in your house, you want insulation to keep the heat from coming in. So it's not necessarily that we're trapping heat or we're trapping cold. Now granted, we're not going to discuss it too much more in this unit. We'll discuss heat more in the next unit. I'll hold that thought for a moment. Hello? That I don't know, I've not seen it, so. Okay, yeah, I marked, I think, about 4 down as absent, and I know. Okay, you bet, thank you. So anyway, if you are an insulator, again, think of heat in terms of, basically, if you're hot, it's because you have a lot of heat. But if you're cold, it's because you don't have heat. Heat goes from a hot object, if you think about it, goes from a hot object to a cold object. Like right now, what direction would heat be going? From here in the building. Out. Yeah, it'd be going outside to where it's colder. But in the summertime, let's say middle of the summer, middle of July, what direction's heat then going to be going? In. Yeah. So think of something, if it's hot, it means it's got a lot of heat that it can radiate off to somewhere colder. If you're cold, that means you want heat to come into you. So if it's cold, that means you have a lack of heat. If you're hot, you've had a lot of heat come into you, or put into you. Okay. So that's conductor and insulator. Now, another one for you. Okay? Take this metal here, for example. What's the difference between this and this? What do you think? What do you think, Mitch? Your eyes have been awfully fixed on that computer screen. You know what I did? Maybe you need to close the computer. So what's the difference between this and this? What's going on here? What's going on with these metals?
One moves more.
Huh?
One moves more.
One moves more. Yeah. Does anyone know what that term is for like a metal that you can take and you can hammer it to like to however you want it to look or shape or bend? That's okay. This one's called malleability. So M-A-L-L-E-A B-I-L-I-T-Y. And malleability is a substance's ability to be shaped and reshaped. I'll say that again. It's a substance's ability to be shaped and reshaped. So obviously metal, certain kinds of metal, you can do that with. Aluminum foil, you can do that really well with. Other metals, it's not as easy to do. Okay? Okay? Then also, you have some metals, like copper, that you can take and try to scratch a surface with it, and it doesn't do so well, but then you can take like lead and scratch a surface with it. How will lead compare to other metals when you scratch a surface with lead? Which is going to make more of a mark? Lead. Why?
It's stronger.
Is lead stronger or is the other metal stronger?
Lead's strong. Lead's not strong.
Lead's generally, I think, like say, how is lead compared to aluminum? How about that? Like a good sturdy piece of aluminum. How does lead compare to aluminum?
Weaker.
Yeah, it's weaker. So this property is just called hardness. So you can just jot that down. There's no particular definition for it, but it's another physical property of a substance. Is its hardness. And I tell you what, I'm gonna have to finish
Hardness?
H-A-R-D-N-E-S-S, yeah. I tell you what, I will finish with that. I've only got about 30 seconds left. We'll finish tomorrow going over definitions, and you'll get your homework, and we'll probably actually get started into a lab tomorrow. We'll see how far we can get. I'm not for certain. It is a pretty quick lab. I think you will enjoy it.
Wow.
Are you guys
Yeah,
gonna
we
do
can
the
deal with
You're not? Are you gonna be here? Can you bring it tomorrow? I don't have a lot of time to talk.
it. See your face all day.
Okay, physical science. That might be pushing it. Let's see.
Do we need these sheets that we crafted today?
If you want them, show me whichever. Worksheet 2 and 3. And I'm not sure. It's all going to depend on the weather. and also just the next couple of days how far we can get. So I might get that far, I might not. Worksheet 2 definitely, but in fact, you want that one, I'm thinking of it, this will be tomorrow's assignment. I don't know about the other one. Okay, thanks, Kyle.
Come on in.
Yep.